Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing one more problem based on solvable for y. So problem solvable for y. Okay. So in the previous lecture, we discussed the introduction of unit 2 and problem based on the solvable for y only. So another important problem is also there in the same method amma. So that is so see the question, y is equal to solve y is equal to yp square plus 2px. Okay. So whenever you get a question in this format, y is equal to something, so then clearly it is solvable for y. Why? Because it is we cannot reduce this equation into rational factors. Okay. So it belongs to case 2 as we discussed in the previous lecture. So case 1 problem is solvable for p. That is our next problem. Okay. So in this problem we are going to discussing now. So see that explanation of this problem. Given differential equation is y is equal to yp square plus 2px. Take it as equation number 1. Why? Because there is no modification in that equation. So y minus yp square is equal to 2px. Send that second term to LHS amma. So therefore take y common. 1 minus p square is equal to 2px. So from that condition derive that y value, y is equal to 2px by 1 minus p square. Whenever you send this factor value to RHS summa, then it will become 2px by 1 minus p square. Take it as equation number 2. So after taking that equation number 2, so that means first we have to derive that y value separately. Okay, that is in terms of x and p. Differentiate equation number 2 with respect to x summa. So therefore dy by dx is equal to, you know very well, d by dx of u into v formula, sorry, u by v formula, d by dx of u by v formula equal to, so v into u dash minus u into v dash by v square. This is the formula. So now by using that formula here, numerator value you can take it as u and denominator value you can take v. V into u dash, write down v value 1 minus p square into u dash. U dash means 2px is there. Again in that u dash, again you have that u into v formula. Okay. So d by dx of again u into v formula. Why? Because you have 2 into px, where p is one variable, x is one variable, not two variables. So therefore you know very well u into v dash plus v into u dash formula apply here. So therefore 2 into p into dx by dx with respect to x, that value 1 amma, so no need to write 2 into p into 1 plus 2 into x into with respect to x for p, so dp by dx. So minus, okay, u into u is nothing but amma numerator value 2px into v dash denominator value differentiation 1 value 0 and p square value minus 2p and again for p dp by dx by v square. V square is nothing but 1 minus p square whole square. Okay, as the formula is amma, so we have to follow that formula, d by dx of u by v. So first this is total v value and u dash minus it is a u value and v dash by v square. So that is the total explanation. Now send the denominator value in RHS, send to LHS sum of p. So you know very well dy by dx, where dy by dx is equal to p. So dy by dx is equal to p. So that automatically LHS value will become p and this is the denominator value from RHS. So p into 1 minus p square whole square is equal to, so wherever you have dy by dx, substitute p. So 2 into p, multiply that value 2 into p into 1 minus p square plus 2 into x, 2 into x into. So therefore here you have to multiply this 1 minus p square with 2p and you have to multiply that 1 minus p square with the second term. So therefore 1 minus p square into 2p plus 2x into 1 minus p square dp by dx. Next multiply this value minus into minus plus 2 into 2 4p into pp square 4p square x by x into dp by dx. Now after doing that take all the RHS values to LHS and rewrite that equation p into 1 minus p square whole square. RHS values, if it comes to LHS summa, then all these terms will become negative. So therefore minus 2p 1 minus p square minus 2x 1 minus p square dp by dx minus 4p square x into dp by dx is equal to 0. Now from the first two terms, take 1 minus p square common. From the first two terms, take 1 minus p square common. So take p into 1 minus p square common. So therefore remaining terms are 1 minus p. Okay. So p and 1 minus p square we have taken common. From the square, if you take one term common, again 1 minus p will be there. Okay. Minus 2. So therefore, and from this term minus 2x dp by dx. Remaining two terms, if you take minus 2x dp by dx common. So therefore 1 minus p square plus 2p square equal to 0. So therefore now multiply here minus p into p square minus 1. Okay, from this term take minus 1 common, then it will become minus p into 1 minus p square will become p square minus 1 when you take minus common. And here, so 1 minus p minus 2 value will become p square minus 1. We are multiplying with the total value with that equation. So therefore you will get that value minus 2x dp by dx 1 plus p square equal to 0. So therefore now from that condition you will get here, if you take again minus common from this step minus into minus, here you will get plus p into p square minus 1 and p square plus 1. From this term this term will become p square plus 1 and remaining terms minus 2x dp by dx 1 plus p square equal to 0. So therefore, so now take this p square plus 1 common from the total term, then p into p square minus 1 minus 2x dp by dx equal to 0. After taking p square plus 1 common, now you can observe neglecting the factor not involving dp by dx. Okay, so here you have two factors. This is one factor and this is another factor. So from those two factors, so we have to neglect one factor, which that factor does not contain that dp by dx fact, okay, value. So therefore neglecting the first factor, and we are neglecting this first factor, we are writing only second factor. That second factor is p into p square minus 1 minus 2x dp by dx equal to 0. You know very well p square minus 1. It is in the format of a square minus b square. How you can write a plus b into a minus b. So that is only here we are writing p as it is p square minus 1. P square plus 1 into p square minus 1 minus 2 into x into dp by dx equal to 0. Okay. So therefore now send this negative value to RHS So therefore 2x dp by dx is equal to p into p plus 1 p minus 1. Now so to get that to apply that variable separable method, so by using that variable separable method, all x variables at one side, all p variables at one side, so if you apply that procedure, so you will get 2 into dp. Okay, so 2 will be here only, dp will be here only, and to take this entire RHS value to LHS then it comes to denominator, and send this dx and x value to RHS, then it will become dx by x. That is taken as equation number 2 by using that variable separable method. Okay, so now directly if you apply that integration for this equation number 3, if you apply the integration in LHS, we don't have the direct formula. Okay, integration 2 dp by p into p plus 1 p minus 1, you have this value. We don't know the formula for that value in that integration. So that's why first of all we have to find that value by using that the partial fractions. So therefore before going to apply that integration so here we have to consider the value of that equation as consider, so this only 1 by p into p plus 1 p minus 1, consider that value first of all. So by using that resolving into partial fractions, so you will get that value in this format, 1 by p into p plus 1 p minus 1 is equal to, you know very well partial fractions are nothing but whenever a denominator is in the linear factors format. Linear factors means so whenever the denominator is ax plus b format, then you have to write by capital A by ax plus b. This is the general method for the partial fractions. So here you can see the denominator is in the linear fractions format only. Na p nothing but p plus 0 into x you can write, and p plus 1 is there. Okay, p plus 1 and p minus 1. So in this format we can divide that given fraction, okay, given fraction into partial fraction. So therefore that value we can write a by p plus b by p plus c by p1. So three factors are there, amma. So you will get the three fractions, so by a by p plus b by p plus c by p minus 1. So now apply LCM in RHS, amma. So if you apply LCM in RHS, then you will get in this format. So LHS as it is 1 by p into p plus 1 p minus 1 is equal to, if you apply that LCM in RHS, so what is that LCM, amma? P into p plus 1 p minus 1, again LCM. For the first fraction p term will get cancelled, remaining terms a into p plus 1 p minus 1. You know very well how to take that LCM, amma. First fraction is a by p na, multiply that first fraction with LCM. What is that LCM? P into p plus 1 p minus 1. First fraction a by p, multiply first fraction with LCM value, pp will get cancelled. Next to write down the remaining values, a into p plus 1 into p minus 1. Next second fraction, amma, b by p plus 1. Second fraction b by p plus 1, multiply with the LCM, p into p plus 1 p minus 1. Okay, p plus 1 will get cancelled. Write down the remaining values, so b into p minus 1. So therefore b into p minus 1 into p. Similarly, if you do that the same procedure for the third fraction, you will get p minus 1 will get cancelled, amma. So therefore c into p plus 1. So in that format we can write the LCM for that equation. So after taking that LCM, amma, now you can observe carefully. On both sides of that above equation, we can cancel the denominator values. This denominator and this denominator, both values will get cancelled. Then, so 1 is equal to the remaining value we are writing, take it as equation number 4. Now after taking equation number 4, amma, we have to calculate capital A, capital B, capital C values from that equation number 4 by substituting the appropriate values of small p. Okay, so to find A, to find B, to find C, the main logic is we have to substitute that p is equal to some real numbers. Okay, randomly you can substitute by trial and error method. First, if you substitute p is equal to 0, okay, so if you substitute p is equal to 0, b value and b term, c term automatically will become 0. Why? Because where p is in the multiplication, 0 into something multiplication, so the total value 0 na, so therefore then you will get only a term. So therefore when you substitute p is equal to 0 in equation number 4, in LHS there is no p term, so write 1 as it is. In RHS, a into, in place of p substitute 0, 0 plus 1, 0 minus 1, plus b into something that 0, c into 0, 0. So directly I am writing instead of substituting p equal to 0. So therefore a into 1, a into minus 1 means a is equal to minus 1. Actually where you will get a into 1 minus 1 is equal to 1, so therefore minus a is equal to 1, we are writing a is equal to minus 1, that value. Okay, so therefore now if you substitute p is equal to 1 in equation number 4, then you will get LHS 1 only equal to, so when you substitute p is equal to 1, a term will become 0 and b term will become 0, only you will get c term, c into 1 into 1 plus 1. So therefore from that condition you will get c is equal to 1 by 2. To get that capital B value, substitute p is equal to minus 1. So ఇక్కడ ఈ 0, 1, minus 1 ఎలా సబ్స్టిట్యూట్ చేయాలనేది మీకు కామన్ సెన్స్ అంటే మీన్స్ మినిమం ఐడియా ఉంటుంది by seeing that equation number 4. Okay, so therefore 1 is equal to, when you substitute p is equal to minus 1, first term a term will become 0 and last term c into term will become 0. Then only you will get to b term only, so b into minus 1 minus 1 minus 1. So therefore 2b equal to 1, b is equal to 1 by 2. So therefore we got that a is equal to minus 1, b is equal to 1 by 2, c is equal to 1 by 2. Three values we got by using the trial and error method, by directly substitution of that p is equal to 0, p is equal to 1, p is equal to minus 1 in equation number 4. Now after getting a, capital B, capital C values, Substitute those values in equation number 4, amma. Then you will get 1 by p into p minus 1, p plus 1 is equal to a value minus 1, minus 1 by a by p means minus 1 by p, b value 1 by 2, 1 by 2 into 1 by 2 by p plus 1 means 1 by 2 into p plus 1, c value also 1 by 2, so therefore 1 by 2 by p minus 1 means 1 by 2 into p minus 1. That is taken as equation number 5. Now substituting equation 5 in equation number 3. Okay, so now come to equation number 3, amma. So this is the equation number 3. In equation number 3, wherever you have 1 by p into p plus 1, p minus 1, in that value you have to substitute equation number 5 values. So therefore from equation number 3 we are writing, what is that equation number 3, amma? 2 into, okay, so I will explain, 2 into dp. Equation number 3 is 2 into dp by p into p plus 1, p minus 1. So this is that equation number 3. So just in this part, amma, in LHS only we are substituting. 2 will be as it is 2 only, and 1 by p into p plus 1, p minus 1, in place of that value we are substituting RHS of equation number 5, minus 1 by p plus 1 by 2 into p plus 1 plus 1 by 2 into p minus 1 dp as it is, equal to RHS of equation 3 dx by x. Now multiply with 2, amma. In LHS minus 2 by p plus 1 by p. Okay, why? Because if you multiply 2, amma, 2 will get cancelled, again 2 will get cancelled in second fraction and third fraction. So first fraction minus 2 by p, second fraction 2 will get cancelled, amma, in third fraction 2 will get cancelled. So therefore dp is equal to dx by x. Integrating on both side, amma, now you can apply that integration. Why? Because we have the formulas directly. Integrating on both side, then we can easily obtain that integration values from that given formula, amma. So therefore you know very well, integration minus 2 by p dp plus integration 1 by p plus 1 dp plus integration 1 by p minus 1 dp is equal to integration 1 by x dx. Minus 2 constant take outside, amma. So minus 2 into 1 by p dp value integration 1 by p dp manaku log p. Okay, and plus 1 by p plus 1 is there, so it is in the format of f dash of x by, you have to use here f dash of x by f of x integration dx is equal to log f of x, log mod f of x plus c. Okay, this formula you have to use. In the denominator, if you take this denominator p plus 1 value as f of x, if you take this p plus 1 value as f of x, it's a derivative with respect to p. With respect to p derivative, what is that, amma? 1 plus 0. P derivative emo meeku 1 aitadi. P plus 1 kada. P plus 1 ki derivative apply cheste p derivative 1, 1 derivative 0. 1 plus 0 means 1 only na. So therefore in the numerator you have f dash of value. This is that f dash of value, f dash of x value. In the denominator you have the function f of x. So therefore integration is also there. Integration f dash of x by f of x dx is equal to log mod f of x plus c. So in that place we are writing log mod, okay, mod p plus 1, or you can write directly mod log p plus 1 plus. For the second term also, here you have log same function, take it is my f of x, amma, and this is the differentiation of that p minus 1 only. So therefore integration f dash of x by f of x dx formula here also applicable. We are writing log p minus 1. In RHS, integration 1 by x dx log x, and integration constant we are writing as log c. Okay, according to the logarithm rules, amma, send the 2 value to power of 2, so therefore minus log p square plus from these two terms, amma, log a plus log b, we can write log a into b, log a into b. So p plus 1 into p minus 1 is equal to, again in RHS also log a into b, okay, log c into x. So therefore from this term, again it is converted into log a plus log a minus log b. So take it is log b and it is log a, okay. So log a minus log b. So ikkada first term ki minus undamma meeku. Here you have the minus for the first two term. Okay, first to take this term as a log a, log a. Here you have minus, take it as log b. Log A minus log B means log A by B. A by B means you can write in this format. Okay. Log P square minus 1 by P square equal to RHS log C into X, or else you can write in this format. So therefore, on both sides by cancelling log you will get P square minus 1. Why? Because P plus 1 into P minus 1. Here you have P plus 1 into P minus 1. So that value P plus 1 into P minus 1 we are writing as P square minus 1. So therefore P square minus 1 by P square equal to C into X. From this condition P square minus 1 is equal to Cx into P square. So take that value to LHS. P square minus 1 minus Cx P square equal to 0. Take P square common from the first term, last term, you will get P square into 1 minus Cx and minus 1 equal to 0. So send this minus 1 value to RHS, then P square 1 minus Cx is equal to 1. P square is equal to 1 by 1 minus Cx and squaring on both sides, applying square root on both sides. So therefore square root will get cancelled in LHS sum. So therefore you will get P. P is equal to square root of 1 by 1 minus Cx. Apply that square root separately in RHS. For the numerator and denominator, you will get P is equal to root 1 ante 1 kada. So 1 by root 1 minus Cx. So therefore that is a P value. Substitute this P value in equation number 6. Sorry sir. Taking as it is equation number 6. So therefore substitute equation number 6, that is P value. Substitute P value in equation number 1. So therefore what is that equation number 1 amma? Y is equal to yp square plus 2 into px. So wherever you have p, substitute that equation number 6 and simplify amma. Y is equal to y into, so here you will get when you separate the square value, square root will get cancel amma, y into 1 by 1 minus cx plus so 2x by 1 minus square root 1 minus cx. Take this term to LHS amma, second term y minus y into 1 minus cx by 2x by under root of 1 minus cx. Take y common from the two terms of LHS, then y into 1 minus cx is equal to 2x by square root of 1 minus cx. Take that LCM here, you will get y into 1 minus cx minus 1 by 1 minus cx is equal to 2x square root of 2x by square root of 1 minus cx. So therefore plus 1 minus 1 will get cancelled in the numerator. In the remaining values minus cxy by 1 minus cx is equal to 2x by square root of 1 minus cx. Okay. So therefore here also this value and this value will get cancelled. Okay. So 2 equal to root 2 unkonamma. So 1 this 2 how you can write? 2 equal to root 2. Then 2 value how you can write amma? 2 value you can write root 2 into root 2 is equal to RHS root 2 as it is. 1 root 2 will get cancelled, then you will get root 2 only. Na? So that is only here we are writing. When you cancel this value in LHS you will get another root 2 value, that is root 2 is nothing but here root 1 minus cx. So numerator as it is amma, minus cxy by square root of 1 minus cx is equal to 2x. So therefore send that denominator value to RHS, minus cxy is equal to 2x into 1 minus cx. So send this value to RHS amma. So therefore 2x square root of 1 minus cx plus cxy is equal to 0. Hence the required solution for the given problem solvable for y is 2 into x square root of 1 minus cx plus cxy is equal to 0. This is the required solution. Okay. So this problem repeated so many times in the examination amma, especially solvable for y problems. There are several problems in your material and question bank amma. So out of all problems, this problem is very important. Why? Because it has some large process. So already you experienced that explanation. So this is the total explanation of this problem. I hope you understood this problem very well. The next lecture we are coming with another method amma. Make a perfect practice. Prepare well. Until bye. Thank you.